When an AI answers you, it doesn't write the whole sentence in its head. It does something much stranger. It predicts one tiny piece of text, then another, then another. These pieces are called tokens. A token is not always a word. Sometimes it is a whole word, sometimes part of a word, sometimes punctuation, or even just a space. Before a language model can read your message, it breaks your text into tokens, turns them into numbers, and sends those numbers through a neural network. Then the model has one job. Given all the tokens so far, what token probably comes next? If I write, "The sky is," the model might predict blue, clear, dark, or full of stars. Each option has a probability. The model chooses one token, adds it to the text, and then does the same thing again. Predict, add, predict, add. That is the loop. So is an LLM just autocomplete? Kind of. But imagine autocomplete trained on a massive amount of text, with billions of internal settings, learning patterns in grammar, facts, logic, code, style, jokes, and human conversations. It is not simply copying one sentence from memory. It is calculating what continuation makes sense in this context. Training starts with a simple game. Hide the next token and ask the model to guess it. If the sentence is, "The capital of France is Paris," the model sees, "The capital of France is," and maybe it guesses, "London." That is wrong. So the training process slightly changes the model's internal numbers. So next time, Paris becomes more likely. Now repeat that billions and billions of times. Inside the model are not little folders full of answers. There are numbers, a lot of numbers. You can imagine them like billions of tiny knobs. During training, those knobs are adjusted again and again until the model becomes very good at predicting text. Modern language models usually use a neural network architecture called a transformer. The key idea is attention. Attention helps the model decide which parts of the text matter most right now. For example, in a long sentence, attention can help connect a pronoun like it to the thing it refers to. But raw prediction is not enough. A model trained only to continue text might ramble, imitate random websites, or answer in strange ways. So models can be fine-tuned to follow instructions. Humans show examples of good answers. Humans compare different answers, and the model is adjusted to become more helpful, clear, and safe. This also explains why AI sometimes makes things up. The model is not always checking a perfect fact database. It is generating a likely continuation. Most of the time, that continuation is useful, but sometimes the most confident-sounding answer is just the most statistically plausible one, not the true one. So when an AI writes, it is not pulling a finished answer from a shelf. It breaks your message into tokens, turns them into numbers, uses attention to read the context, predicts the next token, then the next, then the next, and after enough training, that simple loop becomes powerful enough to explain physics, write code, summarize books, and sometimes make things up with terrifying confidence. It sounds like magic, but underneath, it starts with one question: what comes next?